When I read this article in the Wall Street Journal Sunday, I was kind of shocked because the magnitude of what they're saying right here. The college students who cannot do elementary math. We are talking about adding fractions, rounding numbers. This is elementary school mathematics. But many students at the University of California, San Diego, a top public university, ranked 6th nationally by the U.S. News and World Report, according to the new analysis from the university. But what is worse is that these students at university level, they have been passing all the math classes. They have taken even pre-calculus, calculus, statistics, and they have received an 8 in their math courses. The question here is, why is this happening? You can help me if you're watching this video, no? You can help me to base it on your experience. They cannot round this number to the nearest 100th, which is a 3rd grade skill. I have my own answer, and I want to share with you my answer, or base it on my experience. Welcome to Math Topics. This is an unusual video. It's not solving math questions. It's talking about math education. The article continues explaining, for example, that the AP tests for AP courses are easier than the SAT test is now easier. I'm not talking about that. This is not the problem, and that's an opinion. Okay? That is an opinion. And I respect every opinion, but I know that the AP courses are really difficult. The question is, how is this possible? And why is this happening? Because they said here that the students cannot add or subtract fractions. I think this is the problem. My answer is, or one of my answers is, students are not learning lifetime. There are 2 ways to learn. You learn only to pass the class, or you learn only to have a good grade and move on, or you learn by your whole life, and you understand the hidden features of what you're learning. So I always talk about the two main components of education, of math learning: conceptual mathematics and procedural mathematics. So if you learn the procedure, that you need to find the least common denominator here, and you know that the common denominator here is 6, and you have to multiply by 2 here in order to make a denominator 6, and you multiply here by 3 to make it the denominator 6, and then you have to multiply the top also, and those fractions becomes into 3/6 and 10/6. And now, because the denominators are the same, the answer here is 13/6. This is procedure. And the brain learn it, but cannot keep it. It's just a short time procedure. And this is the gap that we have. So if we learn the procedure only, and we do not have the students to manipulate the fractions, to manipulate what is the meaning of that in a hands-on activity, for example, that they can see the fraction 1/2. They can see what is 5/3 and the additions of those parts. You are not moving that procedure into a long-term memory. And that's why when you don't practice, you forget. But you forget not only adding and subtracting fractions. You forget any other procedure. For example, if you have a triangle here, and you know the area of the triangle is 1/2 the base times the height. This is a formula. Students can memorize a formula. But what is the base? And what is the height? So let's say that this is the height. And this is the base. So this process is also procedural mathematics. But it's not conceptual mathematics, because if you don't talk about what is area, you don't talk about what is area by visualizations, by making the students doing it like this, the brain, it will forget. It will forget. Maybe can't remember the formula, maybe can't remember this formula, but maybe is going to forget what is area. And then it's when the students, they don't know what is perimeter, or they don't know what is area, or they have no idea that, I don't know, the perimeter, it's the sum of the sides. And the area is all of this inside. And why we use square units. How we use square units or unit squares. So now when we finish, we do this. When we finish, we do this. And when we find the perimeter, we don't use square units. We use linear units because it's distance. So I know the answer. The answer is that if we teach procedures, but not the understanding behind the procedures, the students or any person in this world is going to forget. Is going to forget any other procedure. So you can move this. You can move this to calculus, and you can say here, I don't know, the function f of x is equal x to the second power. I want that you find dy dx. Oh, what was that? Dy dx. Oh, it's the derivative. This is so difficult. But I remember how to do it. I remember that this is the power rule, and the derivative of the function f of x knowing that f of x is y, is 2x. You probably can remember the procedure, but what about what is the derivative? Did you learn? What is the meaning of derivative? Oh, yes, I have a function right here, and I don't remember. Oh, you don't remember. Because the derivative is the instantaneous rate of change. Is the slope of the line tangent to the curve at one particular point. Let me use a different color. So you have a line that is tangent at one particular point. The slope of that line is this. So if the point is x equal 1, you substitute the x by 1 and the slope is 2. And that's the combination of concepts, definitions, ideas, and procedures. And this is why, when I read this article, I'm not agree with the justifications of because these tests are easier now than in the past, or this content now are easier than in the past. No. This is not the reason. If you teach art and you have a painting from Pablo Picasso, for example, and you have a person that you need to that need to understand that painting. I don't know anything about painting techniques, but you have to explain them. How Picasso did this, and what techniques he was using, and what that means, and what is the message of the painting for Picasso. So in mathematics, it's exactly the same. You cannot teach adding and subtracting fractions without diving into fractions. You cannot teach rounding without talking about infinity, without talking about that between two numbers, always there is another number. That is a very abstract idea. Very, very abstract idea that is difficult to understand. But if you do not dive into the idea of very small numbers and very big numbers, and the idea of infinite numbers between two numbers, you cannot talk about fractions. And learning the rest of the mathematics without that foundation it will be difficult, struggling, and also the students will forget. Because you forget when you don't see the meaning, when the stuff that you're learning is not making sense for you. So if I tell you what is the rule here, when you find the derivative of x to the n, you know that you do this. This is the power rule. That's why I move the 2 in front and I subtract 2 minus 1 is 1. So this is a procedure, but you are going to forget because I haven't talked about dy dx. And what is it this? And what is the graphing representation? And what is the slope of the tangent line? And it's a universe of knowledge. It's a universe of knowledge. If we don't teach the universe of knowledge, or we try to teach the universe of knowledge, students will not learn lifetime. And that's why they can go to college and they cannot remember how to add and subtract fractions or rounding numbers. I know that I have one of my shorts here that said 1 divided by 0. I know it's not possible. But in terms of approximation, it's possible. It's a really, really, really a big number. When we get closer to 0, if you divide 1 by 0.0001, what happens? And then you teach approximation. And then it's when you talk about the decimal, you talk about the place value. No? But what happens if I come over here and I divide the place value like this, and this is the ones, this is the tens, this is the... No. This is procedure. This is procedure. And this will be totally forgotten. They will not do this again. They're never going to remember what is the location of the ones, what is the location of the tens, what is the location of the 100, etc. Because we are teaching just procedures. You place the number right here in every slot, and every slot has a name, and that's the location, and then you find the digit that is in that location, and you check the number after. If the number after is 5 or greater than 5, you add 1. This is no lifetime. This is, I can tell you, black and white, this is no lifetime learning and lifetime teaching. This is a building. Mathematics is a beautiful, powerful, difficult, complex building. And we have to navigate through the building by levels, by layers. Because, for example, you start with the line, and then you put the line in the coordinate system. And you start with 2 points. And then it's when you talk about the rise over run. So you navigate through different, let's say, floors of the building. I have said that in this channel many times. This is what Euclid did in geometry. When you read the elements, Euclid start with that point, and then with another point, and then with the line, and then with the triangle, and then he constructed the building of plane geometry like that, with elements, like a big puzzle. So when I read this last Sunday, I told you, I said I had to talk with in my YouTube channel to my audience what they think about this. What is the response about this? Always, your comments are welcome. But I have my answer. My answer is, how do we teach math if we are teachers? And how do we learn math if we are students? And we are teachers and students at the same time, because we always learn. The brain is wonderful, it's beautiful. But we have to feed the brain with the food that the brain likes. And the food that the brain likes is the integration, the navigation from simplicity to complexity, from mastering simplicity to mastering complexity. The brain likes to understand the logic and the reasoning behind the procedures. What is the support of my actions? That's the way the brain loves. And this is the way all the time that we have to teach any subject, any things, any topic, because that's the way that it will last forever. Thank you for watching. If you like the video, don't forget to give us a like and consider being a member of Math Topics membership. Thank you. See you in the next video.